Basically, in this tutorial, I want to focus on creating the hypsometric curve or doing a hypsometric analysis. So to give a brief about what hypsometric curve is or hypsometric analysis does is, so hypsometric analysis is an important geomorphological technique used to evaluate the relationship between elevation and then the surface area within the drainage basin. So if we look at its importance, it helps researcher understand the geomorphic development, degree of dissection and erosional status of a landscape. So by analyzing the distribution of area across different elevation through hypsometric curves and hypsometric integrals, geomorphologists can infer whether a basin is in youthful stage or mature stage or old stage of cycle of erosion. So the stages of youthful, mature and old age in erosion are mainly associated with Davison cycle of erosion proposed by William David Morris, not William Morris Davitt, I guess that is correct, in the late 19th century. So according to him, or according to Davison model, landscape evolved through sequence of stages after tectonic uplift. And then you have classified into three stages: youthful, mature and then old stage, where in youthful stage you will find high relief and steep slopes, deep river valleys, active vertical erosion, limited dissection of landscape, and then corresponds to high hypsometric integral values and the convex hypsometric curve. Then mature stage, where the relief begins to decrease, valley widens due to lateral erosion, drainage network becomes well developed, represented by S-shaped hypsometric curve. And then finally the old stage, where low relief and gently undulating terrain, extensive erosion and peneplain formation, dominance of depositional processes associated with low hypsometric integral values and concave curve. So out here, while we do a hypsometric analysis, we will use, or I will use, the DEM, digital elevation from NASA or Copernicus Hub as well, or you can look for other DEM data such as SRT. You can also use the SRTM data. So in order to do that, I will work with the Amochu basin in order to identify the stages of rivers or the basin. So first of all, you have to load your DEM and then you will go to symbology of your DEM, and then you have to select the primary symbology should be classify, and then method should be equal interval, and then classes, the highest class, that is 32. Now you can just close it, and then you can see out here. So if you just expand this one, the yellow color represents the low elevation, and then the red color, which is around, ranges from 4,489 to 4,634, is the highest elevation of this particular DEM. The next thing, you will go to toolbox, and then you will scroll down and then look for spatial analysis tool out here, spatial analysis tool. Then go down, just scroll down, and then you will click on reclass and then click on reclassify. Your input raster will be your classified digital elevation model, and then you have, let's say, 32 classes. Just click run. Now you have reclassified DEM. So right click and then go to symbology, and then out here you will select unique values, and then you will be able to see all your 32 classes here, which you can see out here represented by different color. Then you will go to again geoprocessing toolbox, and then you will look for zonal, and then you will select zonal statistics as table. So your input raster or feature will be the reclassified DEM zonal field value. Input value raster will be your DEM. Then you will save it somewhere else and then name it as zonal statistics or something different as per your convenience, and then you can run. So once the process completes, you can see out here as zonal statistics. You can open the attribute table, and then you will be able to see the count, object ID, value. So value from 1 to 32, then count, area, minimum, maximum, range, mean, standard deviation, sum. Okay, so the area is in meter, and then if you want to convert it into kilometer, you can do that, or square kilometer. Then you have to save or like export. If you have not saved in your computer, you can right click data, export table, and then name it as hypsometric curve or hypsometric data or whatever, or zonal statistics in folder where you want to save, and then just click OK.